Can everyone hear me? Are we good? Okay, so hi everyone. My name is Ariel. I'm from Ceragon Networks. And today I'm going to show you two demos which we're doing together with Telefonica and Cosmos, who are providing the DPI engines. And we're going to show you how you can use SDN and NFV in order to optimize that wireless microwave backhaul. Now, what we're really trying to do here is take a wireless mobile backhaul that connects your core and the axis, and today is very static, over-provisioned, and very vendor-specific, and to change it. Okay, so we want to change it to something much more programmable, much more dynamic, less provision, and much more open. Okay, that's our concept. And in order to do that, we're tackling this task from 2 points. Okay, so first of all, we're taking our IP20 platform, which are the elements you can see here, and we're extending them. Okay, we're adding OpenFlow capabilities, we're adding NFV engines, okay, very programmable forwarding engines and radio cores. And the other thing we're doing is that we're developing SDN applications over an SDN controller, in this case an Open Daylight. So in this example, the topology we're going to be using is, again, it's a live demo running on this side, okay, composed of the IP20 platform. It's composed of the IP20N elements, the gray elements. I've got two microwave links, this microwave link and this microwave link, which correspond to this link, okay, and this link. I've got an Open Daylight that's controlling all my elements through OpenFlow. I've got SD applications running over the Open Daylight. I've got NFV cards in the edges of my network running a DPI engine for Cosmos. And I've got a media server on one side and 4 agents on the other side playing the videos. So now I'm going to actually move to the demo. So again, this is a live demo, and this is the Open Daylight topology of our setup. I also have a GUI that's currently showing the live traffic running here. Okay, but I am going to switch to video because the Wi-Fi simply isn't good enough to show the videos I want to show here. So I'm just going to move on to video. So if I start it up, what we're looking at is currently traffic going through the primary path, which is up here, and we want to focus on the green traffic, okay? Now, the green traffic is composed of different applications. Okay, applications you can actually see here with the Cosmos DPI engine. Okay, so we see a bunch of Trump sessions running over different operating systems. Okay, we've got Linux, Mac, and we've got Windows. Okay, if I go, I can actually see real videos playing here. I've got 4 video sessions running here. Now each one is on a different operating system. What I did is I played with the user agent, so we're simulating different operating systems, and obviously this is just an example. I could also think about, differentiating between Netflix and YouTube or anything similar. So again, focus on the green traffic, and what we're going to do now, we're going to simulate some rain. Okay, we're going to simulate rain on this microwave link. Now, when you've got rain on a microwave link, okay, which is this situation, the capacity shrinks, and what happens is that all the green traffic is being dropped, okay, because the blue traffic has a lot higher priority and there's simply no more space. If I go back to my video clips, okay, all the videos are going to be stuck. Okay, so again, because it's live traffic, I simply can't push in any more green traffic, and all the videos are stuck. Now, if I'll go back to my setup, and then I'll simply remove the rain, okay, then all the traffic goes back again, which is the green traffic. Okay, and if I go back to my video sessions, they're going to be playing again. But obviously, we want to do something a little more smarter. We want to perform selective rerouting based on this application information. I want to give the operator the option to decide what should be dropped and what not. So if I go back to my setup, I launch my SDN application running here, okay, and then I simulate the rain again. What you're going to see is that although no green traffic is passing through the primary path, some traffic is going through the secondary path, okay, and that's selective reroute. What I did is I let the operator choose what video streams to stream and what should be dropped. In this case, he chose to push forward the 2 Chrome sessions running over a Mac operating system and drop the sessions going through a Windows and a Linux system. Okay, so again, this is just a small example, and once I remove the rain, okay, all the green traffic goes back to normal. It's reverted. Okay, so if I go back to the video sessions now, all the 4 video sessions are going to play as before. So what I showed you here is the ability to correlate between DPI information or application awareness, okay, and the actual state of your microwave links. Okay, that's our first demo. Now, in our second demo, I just want to pause it for a second. We want to look at something different. We want to look at how you can optimize the spectrum of a wireless backhaul. Okay, I've got 2 microwave links. Okay, a blue one and a red one. Now, in today's planning condition, when you have 2 microwave links with a degree less than 90, with an angle less than 90 degrees, you're not able to use the same frequency. Okay, so I have to use a blue frequency and a red frequency. Now, the reason I use 2 different frequencies isn't because the links are actually disturbing each other. It's because there is a certain chance that under specific weather conditions, they will. And because I'm planning for the worst case, okay, I must use different frequencies for both links. Now in this case, between these 2 endpoints, I actually have 2 microwave links, not 1. But the problem is with today's situation, I don't have a color for the other microwave link, okay? So I can't provision it. I can't use blue and I can't use red, okay? Because I'm planning for the worst case. Now, what I'm going to show you is an SDN application that's able to provision this link. It's basically monitor the different spectrum, the different frequencies being used. It will identify the extra link, and it knows how to handle the 0.1% of very rare rain conditions and handle it properly. So if I spit it up, so what we're basically seeing here, that I'm trying, look only at the red bar is the one that interests us now. We've got about 150 megabytes of traffic that we're trying to push all the way to this side, but only 80 is passing through, and it's going through this link. This link is currently totally consumed, and the capacity here is only 8 megas. So even though we have 160 megas to push through, only half is actually passing. Okay? Now, once I invoke my application, okay, what I do is I automatically provision another microwave link using the same color, okay, as before, so I can practically double my capacity. But again, the trick is not that I doubled my capacity. The trick is that now I'm monitoring this is something dynamic. So if I have a rain condition, okay, and now suddenly I have this condition of one microwave link interfering with the other one, okay, the application is going to gray out the extra link, okay, basically turn it off, only for the duration of time that I still have this rain condition, okay, and then I go back to my previous case where only half of the capacity is going through. But once the rain condition disappears, okay, so I go back to my full capacity. So what I'm basically showing you something, I'm showing you something it's kind of trivial, but it's something that's not being done today, okay? I'm dynamically changing a spectrum in a wireless mobile backhaul. So if I sum it up, so what we showed you are 2 examples of how you can really optimize the wireless mobile backhaul that currently is very, very static. It doesn't change. It's not programmable, using concepts from SDN and NFV. So again, it's in a live IP20 platforms running here. And for any more questions, you're welcome to meet us at booth 6. Thank you very much.